Hi students, this is Mr. Yang. Today we're going to talk about 10.4, where we will learn about conditional probability from frequency table. We have a very long example, but it is a very real-life related example. That's kind of how a lot of drug or medicine companies make their trials and study if their medicine works or not. So let's have a look. A develop understanding task about virus. Part 1. Have you ever had chickenpox, measles, just a bunch of virus, then for the rest of your life, you will have the antibody for those diseases in your blood. And a simple blood test will be able to detect the presence of those antibodies. In a similar way, if someone has tuberculosis, then they will have antibodies for that in their blood. Blood tests are designed to detect the presence of specific antibodies, but the tests are not perfect. Just like our COVID vaccine right now. Sometimes, even if there are no antibodies present, other factors will trigger the test to come back positive. So a positive test result isn't absolute evidence that the person has the disease, which is also something we refer to as false positive. To test for TB patients are administered a skin test, which involves injecting a bubble of serum underneath the skin. Then several days later, observing the skin to see if the person has shown a reaction to the serum. A skin reaction indicates the presence of TB antibodies. Suppose that a young adult with no prior evidence of TB has a skin reaction to the serum. The person wonders, do I really have it? Below are the test results from a large sample of people from countries with insufficient health care. So let's have a look. Let's finish the table first. 361 plus some other number is going to give us 423, so it's got to be 62. Horizontally, 361 plus something else is going to give us 380, that's 19. Add these two together, 620. Add these two together, that's 577. And the total is 1,000. What percent of the population of people from these countries are infected with TB, or in other words, has TB antibodies? Right here. That's has. So 380 out of 1,000 is going to be 38%. What percent of the individual in those countries will have a positive test result? Positive test result right here. 423 over 1,000. That's going to be 42.3%. How accurate is the TB test? Well, when we say how accurate, if you think about it, there's two different ways to actually show it's accurate. One is when a test is positive and they actually have it. So that means, yes, it tested right. The result is correct. Or on the other hand, it could be if the test result is negative and they actually do not have it. That is still accurate. So we're going to add these two numbers together, 361 and 558. That should be out of 1,000, which is 919 out of 1,000. So 91.9% accurate rate. Part 2. Identify the cells in the table that show counts for the number of individuals who got inaccurate test results. And put a big frowny face on those cells. Right here. And right here. These are the inaccurate test results. They test negative, but they actually have it. Or they test positive and they don't have it. Out of all those who tested positive, what percent of individuals actually had the antibody? Test positive has antibody. So that's going to be 361 out of 423. And we are going to change that into a decimal or percent. That's 80.85342. 85.34%. Next, out of all those who tested negative, what percent of the individuals didn't have it? Test negative and doesn't have it. So it's 558 over 577. That's going to be 90.96707, rounded to be 96.71%. Next part. Number 7, what percent of those with TB tested negative? The test says they are free, but they actually have it. So that's a false negative. What percent of those with? So this time with, and actually test 19 out of 380, which percent is 5%. What percent of those who test negative didn't have? So test negative, but actually didn't have. So that's going to be, well, actually, what percent of those test positive and have? So that's 62 out of 423, which is going to be 0.14657, which rounded to be 14.66%. So that is the false positive rate. So in case you didn't notice, the definition of false positive and false negative are slightly different. False positive is the condition is it actually tested. The false negative is they actually test negative, and they have it. As for the false positive, that's tested positive and actually didn't have it. So again, the first one is they have it and test negative. The second one is test positive and then do not have it. Now let's see, which is worse, a false negative or a false positive? So let's think about it. False negative means they have it, but they test negative, which means they can still carry the virus around and infect others. So clearly the false negative is worse. Most health tests are designed to be very sensitive, so sensitive that they often come back with false positive results. Why do you suppose tests are planned to be that way? Well, you can think false positive is better. No matter what, false positive is better than false negative. Of course, you can kind of elaborate on that, but that's the basic idea. What will you answer the young adult who tested positive and asks, do I really have TB? Well, you can say there's a whatever percent chance that you may have it, so please go test it again and see if you can get a different result. That is the big question about test results and how that affects our conditional probability. Now let's officially define conditional probability. We're going to use this like vertical bar to represent. That is being read as probability of event A given event B. So event B, given part, that is our condition. So example 1, that number should actually be a 6. That's a typo. Vanilla and blue. So first, that is read as the probability of vanilla given blue. That is our condition, which is we're going to look for first. Blue is 12. So 12. Under blue, how many vanilla we have? We actually have 5. So it's going to be 5 out of 12. For the second one, the condition is the chocolate. So we're going to look for the chocolate. It's going to be 13. And out of these 13, 7 of them are blue. So 7 out of 13. Example 2. Cell phone is the condition. For Venn diagram, you do need to make sure you understand how the circles work. So cell phone is actually this whole circle on the right side, which is going to be 10 and the 15. Then on the top, it means out of these 25 cell phone, how many are iPods? Well, this middle part means the iPod because it's also in the left circle. So it's 10 out of that number, which is 2/5. Second one, no iPod. Our iPod is the circle on the left side right here. So no iPod means outside that circle, which is 15 and 6. So 15 and 6. As for the top, we're looking at the left circle and see which part also had cell phone. And of course, is this middle part, so 10 out of 15 plus 6. Actually, not 10. It's going to be the 15. Because we're looking at any part outside the circle, and the cell phone is actually this part right here, so 15. That simplifies to, that is 15 over 21, simplifies to be 5 over 7. And that is everything for 10.4. Thank you.